All right, here we are again. Seem to be alive. What is up? I'm here on a beautiful Saturday in my little streaming closet at a Pleb Lab. We're gonna do the Keysend workshop today, so I'm stoked on that. Yeah, we just finished. There's been some noise going on here, probably noise in the background. I don't have the best mic situation here yet, but you can hear stuff. But yeah, we just finished with Noster devs meet up here at Pleb Lab. Kind of have an event here at Pleb Lab every Saturday, an in-person event. Usually, or sometimes I end up like splitting off and doing my own stream, so just gonna be in here being lonely with y'all. But no, this is cool. I started, I'm gonna go into this a bit more later, but I guess background, like I was trying to think of what to do for next workshop and was just trying to think of cool little features in Lightning that maybe I haven't touched before or I don't understand. And very quickly Keysend came up to me as like, oh, this is a cool feature. I've kind of heard about it. I kind of know it's like a push payment. I know about some apps that have used it in the past, but I don't really know how it works. I don't know how to work with it. And I also didn't really know what to build with it. But I kind of just started from there and tried to learn a little bit. This was a few weeks ago. So this is the culmination of like kind of the most simple project I thought I could boil it down to, and turned that into a presentation over the last 2 days basically. So yeah, I think it's gonna be pretty cool. Let me switch to my normal view here. Cool. Yeah, so I've got this pulled up here. Yeah, so before we get into it, I'll give it another minute here, because kind of when I get started, I want to blow straight through it. I mean, not super fast, but quick enough for like a recording, because I know like I'm not editing any of my recordings right now, but for these workshops, I do want to try and make the majority of the content like synchronous and easy to just chop up and watch in 45-minute chunk or something like that. But we'll see. Usually I end up getting stuck on something or something breaks, which is always fun. But yeah, keysends are interesting. I had this thought today, like how many people are actually developing with keysends? Like how many people are developing with Lightning at all? Very, very little. A few thousand, maybe 2,000 people. I don't know. Maybe a few hundred. But then when you get down to like something like Keysend, like there's been a handful of companies that have ever used it in any kind of product or feature. A handful of developers who have actually built something with it. You're kind of getting into the niche of the niche, and that's exciting for me. Because it's like, man, what could you build with this? Maybe I'll have an idea, maybe I'll have an insight, or either way, it's just cool experience. Something I heard recently was like for one cool feature I've heard recently is from the Bitcoin company. Apparently, one way they do their auto withdrawals is with Keysend. So, I mean, that was cool. That was a new feature. Hadn't really heard about before, or a new use case for Keysends. So anyway, there's a few things that were like on my mind, some of the context when coming into this workshop. Yes, with that said, I guess we can kind of get into it. I have a link here for the slides. You can find it here, tinyurl.com/Keysend workshop. This should work. Let me double triple check it for you. And these slides will be important. Yep. Because this has all of the code in it. Kind of slide by slide, tried to break it up, commented all of it. But yeah, so if you're gonna be following along, kind of copying along, it will be good to grab the slides here, open it up in a tab. And then I've got the repo right here. And this is the finished project as it currently stands. And we're gonna build it exactly like how I have it here. But yeah, if you just want to run the final project or see it, or maybe you're trying to figure out your dev environment, yeah, you can find it here. When did I start? When did I push my first commit on this? I'm kind of curious. Oops. May 24th. Okay, that was a little while ago. Cool. So link to the slides here. And yeah, I'll probably pull it up again later if anyone joins along and needs it. Okay, prerequisites. I just wrote this like 3 minutes ago because I was thinking like this is a bit of an intermediate workshop because there's a lot of stuff that we're going to touch here that in other workshops, in other live coding sessions, like I'll spend a lot of time on it. We'll really explain it, soak it up. But here, we're kind of just going to be focusing on Keysend for the most part, that feature, and how and a little bit of the infrastructure around it. So yeah, basic understanding of Lightning is going to be required, which is probably the case with all workshops I do, but you never know. Basic understanding of Node.js and APIs. We're going to work with some server stuff. You're not going to have to think about it too much, but there is a lot there for you to dive deeper, maybe once you have it working or taking a second pass. And then my favorite dev environment here for Lightning, Polar, which runs on Docker. What is up? Happy Saturday to the plebs only. Yes, happy Saturday. So yeah, Docker and Polar for the dev environment, and that's about all the prerequisites you'll need, assuming that you have a coding environment at all. And yeah, I think we can kind of get into it. So once again, Keysend workshop at tinyurl. This is where you find the slides. But let's jump into it. So the overview, I guess we're going to learn about Lightning Keysends. We're going to build a simple Keysend messaging app, maybe something you didn't even know could be done with Keysends. We're going to do this with Node.js and React. And so this is kind of what we're going to talk about. What are Keysends, the advantages of Keysends, some considerations, and then a bit of a closer look. Right? We're really going to see at the most granular level what is happening with the Keysend that differentiates it from a regular Lightning Network payment or invoice. And then we're going to go through the demo project. And I will kind of do what I assume you're going to do from home. I'm going to spin up a new project and just going to go through and paste it piece by piece, and then we'll run the demo at the end. And I think it's pretty cool. So what are Keysends? They're a feature of Bitcoin Lightning Network that allows for spontaneous payments without needing a pre-generated invoice from the recipient. So Keysend was introduced in LND version 0.10. That was a while ago. So this was like really long time ago, like 2019. So it's been around for a while. People haven't used it that much. But yeah, it requires only the recipient's node public key, effectively enabling some sort of tip or donation feature, right? We're pushing a payment to them. And so yeah, Keysend, it's a one way. There's no handshake. And if we look normally there is a handshake kind of process, a back and forth that happens with Lightning payment. So normally to receive a Lightning payment, the recipient must first create an invoice, which the sender then fulfills. With Keysend, that's not necessary. The sender can simply push the payment to the recipient's pub key across the network. This is akin to how traditional cash transactions work, where one party can just hand over the money without a formal request. It's also like the experience that most people are used to on-chain. This is why there's so much effort for like LNURL, for Bolt 12, for these different protocols or abstractions on top of Lightning that allow you to just push a payment or push any amount payment to someone. Yeah, so this is the normal like invoice flow. We've got just a back and forth like between the sender and recipient. You know, someone makes an invoice, they pass it back to the person to pay the invoice. The person that pays the invoice presents basically a hash that proves that they paid it, and then you're like, okay, you know it's finalized at that point. Versus just a single direction push payment, and makes it or it doesn't. So that's what's so cool about Keysends. Some considerations though, I think we're going to get into. Advantages. Okay, well, advantages first. We kind of talked about them, but streamlining transactions, no need for invoice generation, just speeds up the process. Just enhances the user experience overall. Spontaneous transactions, push payments. I like the term push payment. I put it in here a lot. But yeah, that's the big idea. Nothing too mind-bending. But how it works is it was a little bit funky under the hood for me. At least some of the details of it. So we'll get right into that in a sec. So all you need is a route. Kind of mentioned all these nice like phrases about how it's a push payment, it's easy, it improves the user experience, but this is a big consideration here. You need to have a route to this person that you're pushing the payment to, just like a normal payment. But this does kind of raise the barrier in entry, because if you're key sending to someone, seemingly, they have a public key, they need to have a node or someone, some custodian that you're pushing a payment to, I suppose. But yeah, all you need is a route. You don't need to have a direct channel with them. This is something I originally thought, I mistakenly thought, that I needed to have a channel directly with someone to push payment to them. But we'll see later that is not at all necessary. We just need a route through the network. So, Keysend messages. We've talked about Keysends. So messages come on to Keysend is a pretty unique feature. We can basically send data along with a payment, adding a messaging capability. So in a Keysend transaction, the message is typically included in the dest custom records field. We'll look in this later. It's just a field on the payment request. And is usually encoded in a format like UTF-8. This functionality turns a simple payment protocol into a powerful communication tool. Enables a lot of use cases. I mean, payments with chat integrated, the encryption that comes with the Lightning Network. Like there's definitely a lot of things you can do with this. It kind of expands the mind. And so Keysend messages, they're not limited to text. You can really include any kind of data that will fit and can be routed over the network, convert it into bytes, fit it into this Keysend, into this push payment. And essentially falls into this dest custom records field, which is destination custom records. We can, not only can we push these payments, but when we push them, we can add whatever arbitrary data that we want to. So Sphinx was the first Keysend chat app. You've probably heard of them. They kind of blew everyone's mind in 2019, from what I remember. Like everyone was really excited about that as an idea because it was Lightning still felt early in the sense that people were just starting to run nodes and starting to use it for payments. And Sphinx came out and was like, we have an encrypted messaging app that is value for value messaging. You send a message along with a 1 sat payment, is how they did it. It was really cool at the time. Like people were so excited about it. I remember all the podcasts about it. I was excited about it. But I felt like, Sphinx is still around. They're doing really cool stuff. And in fact, they've expanded their whole suite of things you can do around Keysends, around this idea, and just routing data over the Lightning Network in general. So Sphinx is a really cool project. But after this kind of first exciting implementation of Keysends, it felt like it disappeared for me. Like I didn't hear much about it. Sphinx didn't necessarily blow up. They've kind of been quietly building for a while, and you kind of have the sense now, you look around, that this is a feature that's very underutilized, Keysends. That's a feeling I'm left with, though. And so, yeah, reflecting on that and like thinking of Sphinx, I was like, what if I try and build like the most basic pleb version of Sphinx? So that's our demo app today. That's kind of how it came to be. Okay, so considerations when using Keysends. So security, the absence of an invoice request in Keysends, which typically ensures the recipient's preparedness for a transaction, might pave the way for unexpected or unwarranted payments. There's still a lot I don't understand around Keysends, for sure. A lot of the considerations on the edge, I guess you would say. So, what happens when a payment fails? I'm pretty sure we get it back, just like when a regular Lightning transaction fails. But these are kind of edge cases I'm not sure of, and the ability to just push payments like on a click to a user that might not be ready, might not be online. I don't know. There just could be considerations here, so I had to just call that out. And anonymity is another one that's pretty obvious, or should be obvious. You're pushing to a public key, right? So you need to know someone's public key to push it to them. If you dox your public key in the Lightning Network, you're essentially doxing your maybe not, but your real identity with your Lightning node. Maybe you don't want to do that. But of course, even to receive on the Lightning Network, when you make an invoice and someone pays it, you have to give up your pub key as well. So privacy on Lightning is always a consideration, and usually very messy, not easy, and not very many people care about it. But it is something to think about, definitely. What information are you linking with any of these activities you're doing on the Lightning Network, on Nostr, whatever. So just wanted to give a call out to those ideas. So, okay, a closer look at a Keysend payment with LND. So this right here is a payment request. And this essentially is everything that it embodies a Keysend, is right inside of here. We'll walk through it. I'll show you what this payment request is for. And this is code we're actually going to use right here later on. You don't need to copy it right now. Yes, so this is a call to send payment sync, a synchronous method for sending a payment that's on the LND API, right? It's a pretty standard method. You have a request body with a bunch of fields. A lot of them are optional, and you just kind of push the request. They're doing the REST API here, but gRPC is mainly what we use. So they put the request together, send them a payment sync, and they just pass it in, get a call back. So ours is going to look a little bit like this, but much more simple, I think. Okay, so the Keysend is defined in the payment request. That's kind of what we're learning so far. So let's dive into these details. Let's see if I remember all of these. That's why I wrote these comments. So the destination right here, this is the key, the public key we're paying to. It's encoded as hex. We've got an amount field here for how much we're pushing, and then a payment hash. So unique payment identifier generated by hashing the pre-image. So this is something that typically is in a invoice. But we'll see in a second that we have both pieces of a typical payment on the Lightning Network. Someone makes an invoice, someone pays it. We have both pieces of that puzzle in this one payment request right here. We'll kind of see that. So we have the payment hash, that's normal. It's hashed to our pre-image. We have the final CLTV delta here. So this is a time lock value which determines the number of blocks a receiver has to claim a payment. Here the recipient has 40 blocks to claim, right? So I'm pushing a payment. If it's not claimed within 40 blocks, it'll come back to me. essentially that's what the final CLTV delta is. And I think CLTV, that's check lock template verify, check lock time verify, I don't know. Custom records, we talked about this earlier. Custom records include arbitrary data sent with the payment. Here it's used to send a message and a pre-image. So we're sending a message here, we have this number, and then we have some message that we're encoding to UTF-8. And we have another number here, and we have something called pre-image, a custom field for the pre-image of the payment hash. And we're going to touch on this for a second. But this essentially, we have our message, and we have a hash that we're sending here in this custom records that we're pushing to the other user's node. So we've got a timeout here, 60 seconds. We have a fee limit. That's kind of normal. And then this dest features, so this is kind of another field that, so it's required in the destination node. So the destination node has to kind of be configured, not super manually configured, they just had to decide that they are going to be interoperable with Keysends. They're going to accept Keysends. And so we are checking this with feature 9, which is TLV onion payload optional. So this is just this bonus feature. We have to make sure that the receiver supports this feature, essentially. So more on dest custom records. This was the object we saw before. So it's a property, and the payment request can carry arbitrary data. This is where you put that arbitrary data. Custom records alongside the payment. These records are delivered to the destination node with the payment. The keys in the destination custom records object are specific record type identifiers. I didn't really know what that meant at first, but I was like, okay, they're IDs. The IDs mean something. And why they chose these IDs, I guess so far it seems arbitrary to me, but these are the IDs they are. So in the given code, there are 2 custom records used. Each of these records carries different data. So the first record has this key 34349334, carries a message, and yeah, it's encoded as UTF-8. And then the second record, this other key, carries the pre-image of the payment hash. This pre-image is important for the recipient to claim the payment. So each custom record is denoted by a key value pair. The key is an arbitrarily chosen number. I guess I'd already thought about this. And the value is the data to be sent, converted to a buffer, which is, just an encoded object. So, like I mentioned before, in this payment request, we're including the information that is normally across the invoice and paying of the invoice. We're including both of those pieces of information. This is the payment hash and the pre-image to the payment. So by including the pre-image, we're actually giving this other node all of the proof they need, all the information they need to just arbitrarily claim a payment right there. I mean, not arbitrarily, but to claim the payment that was received from them when they decode this data, when they see it. Putting it all together. So in a typical Lightning Network transaction, the pre-image is a crucial piece of information for completing a transaction. The payment hash derived from this pre-image is included in the invoice that the recipient creates. When the sender makes a payment, the recipient reveals the pre-image to claim the payment, right? So normally this is 2 parties that are handling this information and collaborating over it. However, in a Keysend transaction, since there's no invoice being created, the process is a bit different. The sender needs to generate the pre-image and the associated payment hash together, and we just push them hey, look, here's the full package you need for claiming this payment. Okay, so does that kind of make sense? We don't know, I guess we don't know the exact cryptography. We don't need to understand everything that's happening below the surface, but we have essentially this hash just generated from the pre-image. Normally this is a handshake process, but we're doing it all in one push, one request. That's all that a Keysend is. All right, this extra little data, this extra few key value pairs that we're allowed to push to another node. So it's pretty cool. Okay, so that's all the dense, heady stuff. That's kind of what took me a majority of the time to like figure out and understand. And honestly, I was working with this before, started building this before I fully understood everything, and so that's always fun. Okay, now we're at the project. So that's cool, making pretty good time. About 25 minutes of explanation, all of our theory, all of our concepts here. So now we're going to be kind of copy pasting into this. So yeah, once again, if you need the slides, they're here at this link, tinyurl.com/keysend-workshop. And then my repo is also linked right here, Austin Kelsey simple-keysend. Cool. So first step here, we're gonna kind of set up a new project, and I'm gonna do this right along with you, just kind of paste the code in step by step. This is another reason you need access to the slides to grab this code. Okay, let's do it. So, open up a new terminal session. Okay, I'm gonna go into my desktop and I'm gonna make this first directory for simple Keysend. CD into it. And we'll run npm init-y to set up our package.json with just the default everything. There we go. We're going to create an index.js by running touch. So I'm going to say touch index.js. And then this is the command to install all of our packages. So I'm just going to copy this. Okay, cool. I'm just gonna pull this open on my VS Code. All right, so this is where we're starting. And it looks like, so I ran the install command, looks like it worked, our node modules are here. We see these packages here as well. So that's good. Okay, so first big chunk of code here is the server and index.js. So this is the top level of our server. So we're making a simple server here, as simple as possible, and a simple front end here, as simple as possible. So we're gonna start with the server, we'll do the front end. So this is the top level of the server here. We're just, we're bringing in our imports. We're going to both be working with kind of regular HTTP API and WebSockets. If you haven't worked with WebSockets before, that's fine. This code will just work for you, and it might even be a good first exposure, good example. So we set up our .env.config. We actually don't need this. I actually could have taken this out. We don't have environment variables anymore, but that's fine. We instantiate the Express application, so we start up our Express app, we tell it to use JSON, we tell it to use cores, which is just, cross-origin resource sharing. It's just something we have to enable for APIs, for our local API. So we make a port here that we're going to use for our HTTP API, and then we initialize a WebSocket server on a different port, 3000. So we're kind of starting up two different server processes here. And then we have a broadcast function to send data to all the connected clients. So this is just a top level function that will push our WebSocket data. Oops. And then we have a route, our Keysend route. This is where our Keysend logic will live in another file. It doesn't exist yet. we're using that route, and then at the bottom level you can see here we're just listening on our port for our HTTP server. Cool. So I'm just gonna grab all of this and we'll bring it into index.js here. Save that. Okay, so next we want to create a keysend.js file. This will be our route, and we're gonna start by adding our imports here. So I'm gonna copy this. So we'll make a new folder called routes, and then inside of that I will add keysend.js. Okay, and we start here with our importing express so that we can use the router, and then we've got crypto and LND gRPC, which we'll use later. Okay, so first up here in the Keysend route is our listen endpoint. So this is how we'll be listening for keysends on our node or on a given connected node. So first of all, we have an object here to store LND gRPC instances. We might have multiple instances, so we're just setting aside this object to store them. And then after that, that's when our actual endpoint starts, and this is a WebSocket endpoint, as you can see. So as well as kind of an HTTP endpoint together. So first we start this route right here, router.post. It's a post route, and so the user would be posting their credentials to their node for our server to start listening for it. That's kind of the first step that happens here. We're defining a listen route. This is where the user essentially connects, and we try and set up an LND gRPC instance with the information they give us so that we can call some methods on their node. And we add it, we just add it to our object here. We connect it, make sure it's connected. We grab the service that we need, Lightning, and then we get info from the user's node, and that's what we pass back. So we'll say successfully started listening for keysends, and then we'll send the user's alias and their pub key back, so we can kind of just show that you're essentially logged in effectively. So yes, simple enough. So listen endpoint, let's grab all of this and copy it. Get started. Our environment will be yelling at us still. That's fine, because we have another endpoint here, which is next. This is the send endpoint, and this is going to be kind of broken up. This is, I guess, the more complicated one here. Excuse me. Okay, so this is our send endpoint. Once we are connected, once a given user's node is connected to our server, we can start to send payments. So once again, this is a post endpoint. So we're expecting these fields from the client. And we check to make sure that our gRPC instance is still connected. If it's not, we return an error. If it is, get the sender's node info. We define a payment amount in sats. Right now, this is a fixed 1100 sats, which is actually quite a lot, but whatever. We're on reg test, or we're going to be on reg test. We create a pre-image here, and we create a payment hash. And so this is, I guess, to tell you what's happening here, this code snippet we looked at earlier, this payment request, we're kind of building the variables that are going to be passed in here. That's what this step is, right? So part of it is the sender info. Where do we use that? We use lightning.getInfo. I don't even see where we're using the sender info yet, but I think we're using it later down. We're grabbing the amount, and I guess this is the important piece here where we're doing our crypto stuff. We're essentially creating 32 random bytes for the pre-image, and the payment hash gets generated from the pre-image. Okay, So it's a SHA-256 of the pre-image. And these are the two pieces of information that essentially give whoever has them the right to claim this payment. So kind of simple for doing some crypto stuff. So let's copy this. Okay. Next slide is part 2 of this endpoint. We've looked at this plenty. This is our payment request right here. Yep. So payment request that we are going to pass into our pay method, and that will happen right here. So let's look at this one a little bit closer. So is this the end? Yeah, this is the last part of our send endpoint for Keysend. So we take that payment request that we created before, and we're essentially just calling it into the send payment sync method. And then we're putting that response into a payment response variable here. And so we broadcast sent message. What's up, Judy? Emma Swin, thank you so much for the tip. I love this Zebedee extension. I forget I have it sometimes. It scares me. Appreciate it. Yes, so we are this is one of the messages we're broadcasting back to the client from WebSockets here. We've got our host, senderinfo.identity pub key, the destination, senderinfo.alias, essentially like everything that we're going to display on the front end to show the message. So the message that was sent in the Keysend, I guess. And then for the person that sent the message, we kind of return the pre-image and the payment route, or else we error out. Yeah. So that kind of, I guess some of this, like if you're just looking at this at a glance, maybe it looks a little bit overwhelming, but it makes a lot more sense once you're on the client side and you kind of know what information you need, what information you want to display. Because that's how I built this, is like very iteratively. Okay, we save this now, and our full Keysend file is complete. Some pretty dense code, but 130 lines, not too bad. All this is commented here. So cool. Our listen and our send endpoints, they're done. All right. I think next we go into the client side. Yes, okay. So here's where we create our React app, and we're just gonna create it inside of the server. It's all gonna be local, that's fine. And we're gonna do that with npm create vite at latest. We're gonna be sure to name our project front end, and we're gonna be sure to select React. So you can see what that looks like. Open up my terminal here. Call it front end, and we will select React here, and we'll select this JavaScript option right here as well. We don't need TypeScript. I forget what SWC is. I think it's some state management library, but we don't want it, we don't need it. Just do JavaScript. There we go, we have a front end folder now. It's telling us what to do. We can cd into front end, run npm install. For sure, yeah. Will definitely be recorded, like always, and it's one of those things like you could have someone explain it to you, but to get it running locally and to kind of look at each piece of this, to look back at the comments, I think that's where the rubber hits the road, is on a second pass. But yeah, definitely great. This is very much an intermediate workshop. But okay, so we spun up our front end here according to the instructions. And by the way, I'll jump back to this one more time. If you don't have the link to the slides, like all the code is in these slides. I also have the completed project here on GitHub. So definitely visit this URL if you need the slides. tinyurl.com/Keysend workshop. Okay, so start up our front end. And here we're going to start adding code into it. But let's just see if it ran. We did npm install. Let's do npm run dev. It should give us a server here. And I can open it, and yeah, this is like their basic React. Do they count? What are they counting? Count. Okay. But yeah, cool. So that works. So let's start editing this code. I go in the front end, and I'll open up source, and we're kind of going to be touching only 3 files in here. But a majority of it's all going to go in app.js. And we're going to start with some functions. So we're going to have a main app.js component, but it's going to have some functions to render different pieces of our UI. So like this is the first piece of UI that people see. It's a node setup form. All it really does is like render some form fields, and it sets some state. Right? We'll have another function after that for our payment form for when a user wants to pay. And then another one after that to display the messages. So I'm kind of just going to grab all 3 of these in unison. These are pretty standard. It's just kind of, yeah, rendering UI and handling state. So let's start right here. And go to app.js. I'm just going to overwrite all of this. Command all paste. Okay, so there's node setup. Grab payment form. And then message display. Cool. So these are the 3 little rendering functions that we're going to use in our main component. And then next here, now we're going to start to create our actual app. I should have said component. Component. Do all of these say? Yeah, they all say function. That's fine. That's fine. Okay, so I'm gonna paste this in. Then let's look at this. This is the start of our app component, and we just got a bunch of pieces of state here. You know, a little bit messy. If you're trying to optimize a React app, you know, I suggest to clean things up, to separate things, to put them in separate components. But in a way to do it like this was much more simple just for this example project. But yeah, I mean, this is like all the state for the front end. So that's about it. And everything else here is just going to be listening for the WebSocket. So like, okay, here we're setting up a WebSocket connection. We run this whenever it's connected. And we have a cleanup function here. So this function runs when the component is unmounted or before rerunning the effect due to dependency changes. Here it closes the WebSocket connection when the component unmounts. So yeah, this is like this code. I'm still newish to working with WebSockets and React, and this kind of code looks really weird to me sometimes. But this is very boilerplatey in a sense. Like, we're just making sure that we're staying connected or reconnecting based on a state variable that's just flipping back and forth. That's all that this code is doing. So let's go on to the next piece of the app component. All right, and here we have the actual setup WebSocket function. We define a new WebSocket. We're kind of just hard-coded to our local server that we're running. Make sure that we're connected. Handle WebSocket connection. That's this function down here. We're going to do a few things in a second, and then we set our WebSocket connection, right? And that's right here. Okay. So handle WebSocket message. This is actually our function for, we have the WS on message. This is a listener. It calls this function with any message. And this just, handles our message. It parses it. It sets the required fields here. And kind of a lot of this got pretty condensed thanks to ChatGPT. But we're going to console log the message here. And then just kind of take all of the fields and pass them into our WebSocket messages array, right? And we'll display that later. In fact, that's what gets displayed here in the message display. We just map through them. So yeah, just a lot of fields. That's what was, well, and I guess I mentioned this earlier too. The actual Keysend itself is this object. This is the actual Keysend itself, and really it's these few fields are the ones that really differentiate, and this one. But yeah, just this payment request, this is the Keysend, but there's this whole infrastructure and environment around it to be able to, set up the connection and send and listen. That's where I think you could get caught in the weeds on this project. But, that's why I tried to just lay it all out so it would just work, and you can start to decode it, rewrite it yourself from there. So part 3, we've got 2 more functions here inside of our actual app component before we return our JSX. So one is the function to start listening, not getting called yet. We're posting our setup listen data, so this is where we're actually connecting to the server to start listening. Posting the user's host, their cert, and their macaroon from their node. Just repeat post setups. Oh no, 2 more now. Okay. The send payment function here. That's what's calling the post payment data. Oh yeah, right here. And I think we get to our return now. Yep. And here's the final part of our return. There we go. Cool. So handful of function setup. So posting the payment data, as I mentioned before, that gets called inside of send payment. A little bit of abstraction here, but that's what happens kind of dealing with both WebSockets and API. This is us essentially logging in, posting to start listening to a node. And that calls this, this start listening function calls that. Sets all of our state. And then handle messages. We looked at that before. Cool. And then here, this is our return. We just kind of return a few of these pieces of UI that we defined at the top, depending on if the user is connected or not. So if the user is not connected, we render node setup, which is the forms where they start to essentially log in. And otherwise, we'll show that they're connected, we'll show their alias, and we'll give them a payment form. And then, of course, display messages as they come in. And this is a GIF to make the app look cool, which we'll see in a second. Okay, almost at the end here. We just have CSS, right? So I've got a big, I'm not even going to zoom into this. This is just all the CSS I wrote to kind of make this app look not terrible. So we're going to go into apps.css. We're going to replace everything with what we got here. And we've got one more slide of CSS. I'll copy that and I'll throw it at the bottom. Save. And then finally on our last slide here, I'm going to tell you to comment out index.css import in main.css. This is just extra styles that came default with the project. So just to keep it pretty, we're just gonna go in here and comment this out, save that. Okay, cool. So from there, I kind of am telling you how you're gonna set up your polar. And this is actually where I ran out of time today, like making this presentation, but we're gonna step through it and run it right now, but you're gonna have a network that looks like this. And I'll show you that in just a second. So, so let's get out of here, go back to our server level. Zoom in so you can see. And I'm gonna run node index.js, and this is gonna start our server. I'm gonna do that first and foremost. And then I'm gonna open up a new terminal session here for our front end. CD in the front end. We'll run, what was it? npm run dev. Okay, and now our front end is running. So I should be able to go here and yeah. We see this is our little UI. I just used a GIF on the background here to try and make it look cool. Looks all right. But here's the thing: we're not just gonna be on one side of this transaction. We're gonna be connected to two different nodes at the same time locally, and we're gonna have them talk to each other. That's what I want to do here. So this is gonna be our first node. And I have this open in Brave, my Brave browser. And I'm gonna open another one inside of Safari here. And from here, we can spin up our Polar environment. I've already got mine running. Docker desktop needs to be open. And then we have Polar, and this here is my network. And this is essentially the network you want. I've kind of been doing it like I've been connecting to both parties, but I've been doing it one way. And the one way is like I want Alice to pay Carol. And that's kind of my test example. And I want to be Alice paying Carol, and I want to be Carol receiving the message at the same time. And Bob, he's just a route for us. But you notice that Alice and Carol, we don't have a direct channel together, but I'll still be able to keysend to Carol nonetheless. Cool. So yeah, this is the kind of setup you'd want. Bob has a channel open to Carol so that Carol can get paid. Alice and Bob have an inbound and outbound channel to each other. And this is kind of the most simple setup. I'm gonna give, no, Carol's gonna receive sats. Okay, so first I'm gonna connect to Alice in one of our browsers. So I'm gonna go here to the Connect tab, and we're gonna grab gRPC host, copy this first and foremost. And Alice will be our Brave browser, and with the console open here. So that's kind of one of the ways we'll remember, but it'll also show their node aliases. So grab the TLS cert from right here. You can just grab the file path since we are all local. And I'm gonna grab the admin macaroon. And I'm gonna start listening. Okay, cool. And so we are now connected as Alice. We ran a method on Alice's node. We got her alias. And yeah, we sent this message back to the client. So that's cool. I'm now gonna do this for Carol. I'm gonna click on Carol's node here. Grab Carol's gRPC host, put it into Safari. Then we'll grab her TLS cert. And admin macaroon. Right, do we think this is gonna work the first time? I don't know. This will be like the only time that I've done a live workshop that didn't like break or have some kind of unexpected bug. Let's see. So this is Carol. She's going to be receiving. Alice is going to be the one paying. So what we have here, we put in a destination and we put in a message. It's Keysend, so our destination is pub key. So we're Alice here. We're going to grab Carol's pub key, which is right here. And I'm going to add that. And I'm going to put a message. I'll put hey. And let's see what happens. Okay, it says we're successful here. I go back. And there we go. We got a message from Alice. It tells us the host that it came from, 1001. That is not us. Alice said, "Hey," and we've got a timestamp on here as well. So that's pretty cool. That's pretty exciting. And if we go, I wonder if we can like quick mine and see how the liquidity has shifted. Destination balance. Yeah, this isn't. Polar fails to update sometimes with like routed payments. But that's fine. Either way, we see clearly as Carol we got a message. We can send another one just to be sure. Hey ho. There we go. Nice. And we wouldn't be able to send a payment back as Carol, of course, because Carol does not have any open channels. Carol only has an inbound channel from Bob. So this payment flow can only really go one way. But nonetheless, that's pretty cool. And that's kind of the whole thing. We can see here if I go into the inspector, can see the full message that we're receiving, the pub key, the host, all that information we're getting. Yeah, all of that's being console logged from the client. And so there we go. We kind of have a shitpost server now. You know, we can post anything we want to here. Push did 9/11. There we go. Can't censor me. But yeah, that is essentially the full demo. So I guess the parts of the slides I'm missing here would be just showing you how we're running the servers, but you know, that should be straightforward enough. Poor man's Noster relay. Exactly. I actually originally my idea for an app I wanted to build, I wanted to call it 4-channel like this, and I wanted to have it be like a central node that I run, that anyone, if they have a route to me, they could keysend to me, and I'll just post it up on a public board, you know, a public shit posting board. So I was gonna build that, but then I thought about it for a second and I was like, that's a terrible idea. I'm gonna get fucking thrown in a gulag after 2 days if people discovered it. But you could, in theory, you could do this. You could be like, look, here's my node, pub key to me, and I'll post a message, or maybe I'll even censor you, because I could do that too. I'm gonna get spammed, exactly. But they can only spam me with payments. Kind of not true, actually. You can probe on Lightning, so maybe they could do that. But yeah, that is a reason I like to keep things local for a while. Really kick the tires before I go into prod. Not always, but sometimes. But yeah, that is kind of the full walkthrough. You know, like I said before, this is my first Keysend app. I was learning everything for the first time here. Try to boil it down, but who knows? We might do a follow-up on this or find easier method, maybe even build a library or some kind of abstracted hook or function to do some of this for you. But yeah, there we go. That is Keysend's. Nice. So I'm trying to think if there's anything else I want to call out in this presentation. Yeah, I guess we got the full overview done. Yeah, I mean, really the thought to leave with is play around with Keysends, or play around with any of these small Lightning features. There's so few people working on this stuff, and there's so many cool things to be done. We need lots of ideas. And this is, if anything, this is where I fall short a lot of times, is ideas. Like, I'll always just make a very simple template project. But you know, there's a lot of clever ideas, clever ways you can use this feature. I'd love to see more people experiment with. But yes, with that was about a clean hour. Not bad. That was probably my shortest workshop, so that's good. I hope the project was cool to you. I hope you take the code, run it yourself, and get it running locally, review it, improve it, and I'll happily be in the Discord to help you. Message me anytime in the Discord or on Twitter. Be happy to help you with the project, explain something, meet with you. Yeah, definitely try and do that as much as possible. Just connect with you all that, are trying to learn these skills, trying to walk the same path. But yes, appreciate you tuning in once again. This is like the first week I've done 3 streams in a row, I think, or 3 streams in a week, so that's pretty exciting, and I kind of want to keep it up. We'll see. These workshops, they take a bit more prep, so I'll try and keep doing them on the weekend, but I'll at least have my weekly coding stream, live coding and Q&A, and then I'll have my learning Rust stream that I'll continue to do on a week-to-week basis. So yeah, look forward to that. That being said, thanks again for tuning in. Come into the Pleb Devs Discord. I'm trying to help people. I'm trying to level up myself. Devs need to level up together. So let's stay in it together. But cool. See you all next time.